Welcome back to this course on Fundamentals of Computer Architecture. The topic of this lesson is the pipeline organization of the MIPS R4K processor. I complete this lesson with a description of the pipeline organization of the MIPS R4000 or MIPS R4K microprocessor family. This processor family has or had, I don't know if it's still being produced, more than the usual 5 stages, because the instruction and data cache accesses took longer than the other stages and therefore were split into several pipeline stages. To be precise, the first 2 stages are for fetching the instruction. IF is the first half of the instruction fetch and IS is the second half of the instruction fetch. The third stage is the register file stage. Register fetch stage. In it, the instruction is decoded, the registers are fetched, but it is also detected if the instruction cache access was a hit or a miss. For this reason, the instruction memory over here is shown as operating through RF. The fourth stage is the usual execute stage. In it, the instruction is executed. For loads and stores, the effective address is calculated, and for branches, the branch target as well as the branch condition are calculated. Branches are completed after this stage. The 5th and 6th stage are DF and DS, the first and the second half of the data cache access. The 7th stage is called TC, which is the acronym of tag check. In it, it is determined whether the data cache access yielded a hit or not. While it is safe to use an instruction before the tag check is complete and roll back in case of a miss, it's not safe to write the data loaded from the cache to a register until we know whether the cache access was a hit or not, since writing cannot be undone. Finally, the 8th and final stage is the write back stage, in which the result of the instruction is written back to the register file. Finally, in this lesson, I will describe some other features of the MIPS R4K pipeline. First, because the instruction as well as the data cache accesses are split over several pipeline stages, it needs a pipelined or non-blocking cache. Such caches allow starting the next cache access on every clock cycle. Second, because branches take effect at the end of the 4th stage, the branch delay is 3 cycles. But the MIPS R4K also supports the branch delay slot. The effective branch delay is therefore 2 cycles. Finally, the load latency in case of a data cache hit is 2 cycles, because the value loaded is available at the end of the DS stage, the second half of the data fetch. In case of a cache miss, which is determined in the next stage, the pipeline is stalled, and then of course the latency will be longer. This completes this lesson. Thanks for watching. In the next few lessons I will show how code can be reordered or scheduled to improve its performance on a pipeline processor. Hope to see you back.